This question provides an example working with the equation of a circle. The circle C has equation x squared plus y squared minus 20x minus 24y plus 195 equals 0. The centre of C is at the point M. Find the coordinates of the point M and the radius of the circle C. To do that, we need to rearrange this equation of the circle in the standard form x minus a all squared plus y minus b all squared equals r squared, and then we'll be able to identify the centre and the radius. So complete the square for the x's and we get x squared minus 20x gives us x minus 10 all squared. That uses up the x squared and the minus 20x, but it introduces the square of minus 10, which I don't want, so I need to subtract the square of minus 10, so I'm subtracting 100. Deal with the y's next. Got y squared minus 24y, that will be y minus 12 squared, minus the square of minus 12, so that's subtract 144. I've got the plus 195 equals 0. So x minus 10 squared plus y minus 12 squared minus 100 minus 144 is minus 244 plus 195 gives minus 49. And now we take the minus 49 the other side. And instead of writing plus 49, I'll write 7 squared. And so the centre of this circle, M, is the point 10, 12. And the radius is equal to 7. And that completes part A. The next two parts of the question are linked together. N is the point with coordinates 25, 32. Find the length of the line MN, that's from N to the centre of the circle. The tangent to the circle C at a point P on the circle passes through point N. Find the length of NP, so that's finding the length of the tangent. Now a diagram will be a big help here, and I've already drawn this one. We've got this circle centred on 10, 12, radius 7, and this point out in the distance 25, 32. So part B, we're looking to find MN. So I want the distance from N to N. Well, MN, using Pythagoras, is equal to the square root of the difference in the x coordinate squared, that's 25 minus 10 squared, plus the difference in the y coordinate squared, 32 minus 12 squared, which is the square root of 15 squared plus 20 squared. Now you can put that in your calculator, or you might recognise it as a multiple of a 3, 4, 5 right angle triangle, 15, 20, 25. So that would come to 25. So this is 25 units long. Part C, we're looking to find NP. Now P is the point where a tangent from N touches the circle. I've got two choices. I could go either side of the circle, but tangents from a point are the same length, so it doesn't matter which one I use. So let me draw the tangent to here. And we'll call that the point P. And we asked to find the length PN. To do that, I need to complete the triangle and realise that the angle between a tangent and a radius is 90 degrees. And I already know the radius is 7. So in that right angle triangle, I know that MN is 25, MP is 7, and so I can find PN. So PN squared plus 7 squared is equal to 25 squared. So Pn squared is equal to 625 minus 49. Pn squared is 576, so Pn is the square root of 576, which is 24. And that completes the question.